The cyclone is what is dragging these air masses around. And so we have, instead of a stationary front, we have a cold front and a warm front. A cold front to the west, maybe southwest, maybe northwest of the cyclone, and a warm front to the east, maybe southeast, maybe northeast. Exactly where this is will vary from one storm to the next. So, I want you to start getting this picture in your head of a cyclone has a cold front and a warm front. Because the cyclone occurred along the polar front, as it rotates on its west side, it's dragging cold air from the north down to the south, and on its east side, it's dragging warm air from the south up to the north. At this stage in the life of a cyclone, the cyclone has a name. We refer to a cyclone that looks like this as a wave, or an open wave more accurately. Exactly what's a wave about this is not quite clear until we explain about cyclogenesis. This lecture today, by the way, is like a classic chicken and the egg problem. Where do we start talking about it? The chicken that comes out of the egg, or the egg that laid the chicken? No, the egg that laid the chicken isn't right. The chicken that laid the egg, right? I mean, we got to slip in here. So why this would be called a wave, you won't know for like 45 more minutes. But we call it at this stage in its life a wave. And what makes it a wave, or an open wave, is the fact that the cold front and the warm front meet at the cyclone itself. Later in its life cycle, that's not going to be true. So right now, another way to think about it, maybe, would be to say that see how this warm air mass, which is between the cold front and the warm front, see how this nice warm maritime tropical air mass, it touches the cyclone itself. It makes it all the way to the middle of the cyclone. That would be another way to think of it when it is a wave. Now, when a wet cyclone is a wave, at this stage in his life, he's getting stronger. We started off with this little nascent or newborn cyclone on that stationary front, and now he's getting stronger and stronger. By stronger, we mean lower and lower pressure, which means bigger and bigger pressure gradient forces, which means bigger and bigger winds. So this cyclone is strengthening. He's experiencing cyclogenesis. He's getting stronger and stronger. But you know, that cold front and that warm front, we learned on Thursday before spring break, they don't move at the same speed. Cold fronts and warm fronts move at very different speeds. Cold fronts move a lot faster than warm fronts. So if we come back a few days, now don't get me wrong, they're not moving just too fast. Cold fronts are moving maybe 20 miles an hour, warm fronts are moving maybe 5 miles per hour, something like that. But if we come back and look a day or two later, the fronts will have moved. The rotation around that mid-latitude cyclone has moved the cold front farther than it has moved the warm front. Notice that we still have a cyclone that would be correctly described as a wave or an open wave, in the sense that the cold front and the warm front meet in the center of the cyclone, or, if you want to think of it this way, that the maritime tropical, the warm air mass that is between the cold front and the warm front, still touches up there in the center of the cyclone. So this would still be well described as a wave, but that cold front is moving faster than the warm front. In fact, at some point, he's going to start catching up with the warm front. I mean, if he's moving faster, sooner or later he'll catch up. Now the question is, where will he catch up first? Where will that start to happen? Well, it'll start to happen up near the cyclone itself, because this part of the cold front doesn't have so far to move. This part of the cold front has many hundreds of miles to move. It will take it a long time before this part of the cold front catches up to this part of the warm front. Whereas here, this will happen fairly soon. When it starts to happen, you'll get our fifth kind of front, an occluded front. Let me write that word down. An occluded front. Remember we had 5 types of fronts? Warm fronts, cold fronts, stationary fronts, dry lines, and occluded fronts. And I said we can't talk about occluded fronts just yet. Well, now it's time to talk about occluded fronts. Occluded is another one of those creepy old words that's hard to use these days, like latent. You've probably only had one experience with the word occluded in your life, and that is that you had braces. Who wore braces in here? Right, almost everybody. Right? When you were wearing braces, the dentist was not particularly worried about making... My wife's a dentist, so I get to hear about this all the time. Your dentist was not particularly worried about making your teeth pretty. They were making sure that your teeth fit together right so you could chew. Okay? If your teeth aren't lying together right, sooner or later you're going to break them. Okay? They're worried about how your teeth fit together. In fact, when you were wearing braces, there probably were periods of time where like the teeth were hitting funny. Right? There was a period of time where until that tooth moved far enough, you were like knocking the top of one tooth on the cusp of another tooth and it didn't fit right. But now that you are done with your braces, your teeth fit together just fine. The right word for that fitting together is occlusion. Your teeth fit together like the knuckles on your hand. I'm not just pounding my hand here. Your teeth, the little nubby parts of your teeth, the cusps, fit just right together when your teeth occlude correctly. That's probably the only experience you have in your day-to-day life with the word occluded. Well, in the same way, our fronts are starting to fit together. They are meeting up, they have occluded. And we have created an occluded front. I'll come back to in just a second what's going on along the occluded front in just a little bit. But I think that we can agree that at this stage, it's no longer appropriate to call this cyclone a wave or an open wave. Because notice that the cold front and the warm front don't meet anymore at the center of the cyclone. They needed a new point that's not quite at the cyclone itself. It's, in this case, kind of south and east of the cyclone. And this point, by the way, has a name that sounds more exciting than it is. We call it the triple point. The triple point is that place where the cold front and the warm front and the cold front, the warm front, and the occluded front all meet. And it sounds like something exciting must happen with a name like triple point, but actually no. It's not a particularly important place in the cyclone, but it has a name. So that when meteorologists are writing each other emails or sending each other faxes or talking to each other, they can describe things that are happening, right? Southeast of the triple point, we're seeing thunderstorms right now or something, okay? It's just a name. It's so that we have a way to describe that location, but it isn't like something wonderful is happening there. It's just the place where the three fronts are meeting. Another way to tell ourselves that this clearly is not an example of an open wave is that the maritime tropical air mass, the warm air mass that was between the cold front and the warm front, doesn't touch the cyclone itself anymore. It actually only makes it as far as the triple point. So at this point, we now have two reasons to say that the name open wave or wave isn't the right word for this cyclone anymore. Now we're going to call this, rather, an occluded cyclone. Or, more often, an occlusion. What? So we were calling it an open wave before, and now we're going to call it an occlusion or an occluded cyclone. Okay, there's still, let's make sure we're clear about that. This is all a mid-latitude cyclone. But in its first part of its life, it was an open wave, and in the later part of its life, it is an occluded cyclone. Okay? And this is specific to how mid-latitude cyclones work. Tropical cyclones don't do this. They have different reasons why they grow and weaken and so on. They have a different life cycle. But mid-latitude cyclones go through this kind of cycle. Now, I will tell you what I'm going to tell you before I tell you, and that is once the cyclone becomes an occluded cyclone, he begins to die. What does it mean to die if you're a cyclone? To die means that its pressure is returning towards normal, it's rising, it's getting closer to normal, its pressure gradient forces are weakening, and its winds are weakening. At this point, once the cyclone develops an occlusion, he begins to die. It may take a few days for it to die, but it's going to die. The process by which a cyclone dies, which we will learn about in great detail in the second half of the lecture, is called cyclolysis. Cyclone, lysis, death. Cyclolysis means